Hi everybody, welcome back. We are on day 3 of chapter 10.1, Comparing Two Proportions. Our objective is going to be to use our TI calculator to construct a confidence interval for a difference between two proportions. Last lesson you learned how to do that by hand, but today I want to show you how you can do that do step using your calculator. And then we're going to talk a little bit about hypothesis or significance tests that involve a difference between two proportions. And we're going to mainly focus on the state and the plan portion of the significance test. All right, so I want to revisit a problem that we looked at yesterday. And it was a problem that involved back pain, and was an experiment that was done between two groups. So I had you guys calculate the confidence interval of the difference in the two proportions by hand. And as you can see, it's a pretty extensive calculation. There's a lot of work here. Okay, now you can do this on your calculator. So what I did is I took some screenshots here. And I apologize, but there's some glare. But what you want to do is you want to tap Stat and Tests on your calculator. So you hit Stat and scroll over to Tests as you see right over here. All right, and you used the 1 prop z interval back in chapter 9. Now, what you're going to look for is the 2 prop. So since we're dealing with two proportions, you're going to use a 2 prop z interval. Okay, and you can see once you hit enter, you'll be brought to this screen, and it will ask you, what is your x sub 1? So our x sub 1 here is going to be 39. So what is the number of successes? 39 over 57. And for our second group, we have 43 over 55. The confidence level should be typed in as a decimal, 0.99 as opposed to 99%. And then you are going to hit the calculate button, and you will see this interval, that difference between those two proportions, get calculated for you very quickly. And you should see your p hat, and your p hat sub 1 appears here, and your p hat sub 2 appears here. Okay, so now go back, negative 0.3114. It may be slightly different. The calculator is probably a little more accurate because it won't round at all till the very, very end. So you get 0.3114. And for this number, you get 0.11623. So you are allowed to use this, especially if you see it on an FRQ. So here is a tip that I want you to follow. So the formula for the 2-sample z interval for p sub 1 minus p sub 2 often leads to calculation errors by students. As you saw yesterday, it's pretty tedious, and there's a lot of places where it could go wrong. You might even type all the numbers in your calculator incorrectly. So our book says we recommend using the calculator's 2 prop z interval feature to compute the confidence interval on the AP exam. So this is totally fine, but make sure you name the procedure. This is called a 2 proportion z interval, and give the interval as part of your do step. So I know this is a different interval. This was for the second example we went over, but name your interval as part of your do step. So I want to show you guys one more example that involves using the calculator, and that's for this one here. All right, so this one compared 2 random samples of teens versus adults on their use of social media and the internet. And what you'll notice is that they give you the p hat as a percentage, 80%, and your other p hat also as a percentage. So there's a slight trick to it when you are typing it in your calculator, and I will talk about that in just a moment. But remember, this is a 95% confidence interval, and the order that they give you is teens first and adults second. Okay, so just the order does matter, teens and adults. Okay, so again, this was the work from yesterday. So I'm going to show you that how how easy it is to get all of this. You still need to be familiar with the format, but if this appears in the FRQ, you definitely can make your life a lot easier. So let's figure out how this works. So notice here, again, stat test, 2 prop z interval. Notice here, well, how do you get 639? So that is a result of taking the sample size, so it's 0.80 multiplied by 799. Okay, do not, if you type in 0.80 for your x sub 1, you are going to get an error. And I actually had that happen to a lot of students on last year's AP exam. This gives you 639.2. So go ahead and round it to a whole number. I don't think it'll even let you type in. It won't even let you type in a decimal. So round it to the nearest whole number, which is 639. All right, for x sub 2. Okay, remember that was, I believe that was about 69%. 0.69 times your sample size for that group, 2253. You're going to get 1,554.57. Okay, so go ahead and round that up to 1555. Round the 4 up, make it 1555. Make that 639. Adjust your C level. And as you can see here, the interval is a little different from the one that was calculated by hand. And again, like I said, this is probably more accurate than the hand calculation because there's probably no rounding to the end. So as long as you state the calculator function you used, you're good to go. And I'm totally fine with you using this. But again, tell me what it is you used. And as long as you do the other state plan steps, this is totally acceptable. Okay. And this is called the 2 sample z interval. But if you give it the name of the calculator that the calculator has named for it, that's totally fine too. You can call it a 2 proportion z interval for P1 minus P2. Both of those are totally acceptable. Okay, so that takes care of this part of the objective. So I wanted to spend the last half here performing a significance test, or just at least getting us started on how to conduct one of these for 2 proportions. All right, so remember, the null hypothesis is a statement of no difference. So there's 2 ways you might see the null written out. This way, which is my preferred way, just states that the proportions, or the true proportion of each group, is equal, and there's no difference. P sub 1, whatever that may be, is equal to P sub 2. But oftentimes, you'll see it written to emphasize a difference. You'll see it written out like this. P sub 1 minus P sub 2 is equal to 0. Now, these are identical. Algebraically, if you do this, add P sub 2 to both sides, you get an algebraically equivalent expression to that. So I prefer the one on the top. The book may frequently use the difference. They will use this quite often. P sub 1 minus P sub 2 equals 0. All right, so again, I'll show you both just so you are ready for anything. All right, and this slide goes a little bit more into that. All right, so here are the conditions. So remember, there's always conditions. Thank goodness the conditions for this test are exactly, word for word, the same as the 2 sample z interval for P1 minus P2. Okay, so you've got a random condition that involves 2 independent random samples. Or if you're not random sampling, you have 2 groups in a randomized experiment. You have a 10% condition that only applies when sampling. So if it's an experiment, you can skip the 10% condition. And then, last but not least, you have the large counts. n sub 1 times p hat sub 1. And you've got these 4 parts to it. And everything has to be at least 10, greater than or equal to 10. So we're going to look at a problem, and we're just going to start the state and plan portion. And when I see you guys next time, we'll finish up the full test. All right, so I'm going to pause the slide, or sorry, I want you to pause the video and read through this, and then we will go ahead and try to answer these 2 questions here. All right, so hopefully you paused it and you read through it, and we have a study here that compares the true proportion of children who come to school without eating breakfast in 2 different schools. So in one school, there was an SRS of 80 students and 19 missed breakfast. And at school 2, another SRS, this time a bigger sample size, and 26 missed breakfast. And they're telling you that there are more than 1,400 students attend each school. Now that's done to help you see that you're going to be well under 10%. You should be fine. And the question is, do these data give convincing evidence of a difference in the population proportions? And notice that they give you an alpha level. So that's when you start to think, you know what, I'm going to use a hypothesis test here. So for part A, we're going to state appropriate hypotheses for performing a significance test. And we are going to define our parameters of interest. That's very important, especially on the AP exam. And then we're going to check the conditions. All right, so basically we're running through the state and the plan portion. And next time we meet up again virtually, we'll go over the do and the conclude. All right, so for part 1, again, if you do not like this format, this is totally acceptable. P sub 1 is equal to P sub 2. There is no difference in the true proportion of students who missed breakfast in those 2 schools. They're equal. All right, now, the reason why we have a not equal to, let me go back to this side here. Do these data give convincing evidence of a difference? So they're not asking, is it higher in school 1 or is it higher in school 2? There's no indication of direction, and that's why we go not equal to. So again, you can state this as P sub 1 rather. Whoa, I apologize for that. P sub 1 is not equal to P sub 2. That is totally acceptable. I usually prefer writing it like that. But again, your book may favor this method of writing the hypothesis, but it's totally up to you. Make sure to define your parameters. True proportion of all students at school 1 who missed breakfast. P sub 2, true proportion of all students at school 2 who missed breakfast today. All right, now part B, checking our conditions. It's definitely random. So if this was an FRQ, you'd have to write all this out. Random condition, independent random samples of 80 students from school 1 and 150 students from school 2. Remember, they said there was about 1,500 students at each school. So you're well under 10% for both. You don't really have to show math on that. Finally, large counts. So here, they actually, done this before, they actually give you, they just give the counts. 19, 61, 26, 124, all are greater than or equal to 10. Because it is much more of a hassle to go 80 times your P hat sub 1 would be 19 over 80. But, given that form, you could see that cancels out, right? But you can also say, well, 80 times 61 times 80. Okay, but the point is we can just go with the counts and we are all clear, all greater than or equal to 10. All right, so I'm going to end it there, and next lesson, we will finish up the full hypothesis test, and I'll show you how to calculate the test statistic, how to use it on the calculator, and all that great stuff. All right, have a great day, everyone, and I will see you guys again soon.